Walk into any grocery store or thriving garden, and you are immediately hit by a massive spectrum of colors. Bright reds, deep purples, and rich oranges dominate the landscape. In nature, these colors serve as practical biological signals, ranging from invitations for seed dispersal to warnings against ingestion. But a plant is a stationary organism. It cannot pull its roots out of the ground and run away when faced with blistering UV radiation, predatory insects, or creeping fungal diseases. These pigments are the visible evidence of a plant's defensive hardware, synthesized specifically to neutralize environmental pressures. The everyday colors of our fruits and vegetables function as nature's frontline survival armor. Biologists call this massive family of polyphenolic compounds flavonoids. They are the active agents producing this protective barrier. Looking at this diagram, we see the foundational molecular blueprint. It consists of a 15-carbon skeleton, 2 aromatic rings connected by a 3-carbon bridge. Nature makes slight structural tweaks to this base code, branching into distinct classifications like flavones, flavanols, and flavonones. These specific structural variations dictate how the chemical behaves in the wild. A slight shift in a carbon ring turns one compound into a bitter pest deterrent, while another variation becomes an internal cellular sunscreen or a vibrant beacon to attract pollinators. Through this highly adaptable chemical blueprint, the plant kingdom manages its survival and ecological success across almost every environment on Earth. This brings us to a compelling physiological question. What happens to this highly evolved plant armor once we consume it? Our bodies face a constant invisible threat, oxidative stress. Highly reactive free radicals ping erratically, damaging healthy cellular structures. Fortunately, flavonoids act as free radical scavengers. They intercept these unstable threats, bond with them, and neutralize their erratic movement, halting cellular damage. This chemical neutralization is the core engine of the antioxidant and anti-inflammatory activity we observe in human tissue. By consuming flavonoids, we are effectively transferring the plant's chemical shield directly into our own cellular infrastructure. This cellular protection extends beyond the individual cell, impacting the performance of entire organ systems. In the human cardiovascular system, these compounds improve vascular function, help control blood pressure, and enhance overall circulation. They also provide neuroprotective benefits. Over time, regular consumption supports general brain health and reduces the risk of neurodegenerative diseases. On a metabolic level, flavonoids help regulate blood sugar and improve insulin sensitivity. Rather than targeting a single isolated organ, flavonoids act as a multi-system biological defense, simultaneously shielding the heart, the brain, and our metabolic pathways. If these compounds are so universally protective, why can't we simply isolate them into massive, hyper-concentrated supplement pills? The answer lies in a biological catch known as bioavailability. As this section of the diagram highlights, most flavonoids are poorly absorbed in the small intestine. They do not flow seamlessly into the bloodstream upon ingestion. Instead, they require a complex breakdown process that is initiated by our gut microbiota. From there, they undergo phase 2 metabolism in the liver. This converts raw compounds into usable biological agents before they circulate to human tissues. The human digestive system acts as a biological filter. It resists raw flavonoids, requiring a multi-stage metabolic conversion before these compounds can enter systemic circulation. Looking at the limitations section of this chart, we can see why artificial supplementation is difficult. Concentrated doses do not guarantee higher absorption and can interact negatively with other medications. Successful absorption relies on the food matrix, the naturally occurring physical network of nutrients found in whole foods. Flavonoids operate synergistically. Their biological effects are amplified when they are consumed alongside the natural fibers, vitamins, and minerals they evolved with in the plant. The most effective way to arm your body's cellular defenses is not through a lab-made megadose. It requires a consistent, diverse diet of whole plants. To live better, you must eat colors.